This optional section is a chance for you as a user in this course to see where the formula that we utilize so heavily in section 8.2 comes from. This is the derivation of the quadratic formula. Now you'll recall from section 8.2 that if ax squared plus bx plus c is equal to 0, that when we solve for x, we end up with the quadratic formula. The quadratic formula being this equation right here that we used, like I said, very heavily in section 8.2. You're asked to memorize it. I'm not going to sing the song again for you. So anyway, the point being, we want to know where this came from. Is this, some sort of just a genius discovered this equation and now we all use it, or is it something that we can understand where it comes from fairly easily? And the truth is, we can actually understand this very easily. All we're going to do is we're going to go back to section 8.1 and use complete the square. Right? Completing the square was a technique for solving a general quadratic equation, and it worked on every quadratic equation. So why not use it on the generic form? Why not use it here? Walk through those steps one by one, leaving the a and the b and c in there, but just use algebra to keep track of what's going on. So let's do that. What happens? So the first step, remember, is if the a, or the coefficient in front of the x squared term, is not an a, it's not 1, we have to divide through by it. So we're going to divide through by a, and in fact that's what we get right here. We have divided off the a from this term. We have an a in the denominator and the a in the denominator. We divided both sides of the equation by a, right? We just stuck this over a. Oh, let me turn on my little pink cursor. Hang on. All right. So this term right here divided by a, you end up with x squared. This divided by a, you end up with b over a times x. C over a. 0 divided by a is just 0. Okay. Now what we're going to do is we're going to subtract across the c over a term. So subtract. Remember, you move the constant term to the other side, which is in fact what we have right here. Now we complete the square. Remember, what you do to complete the square is half the middle term squared. Now in our case, that's going to be the b over a. So we're going to take 1/2 of the b over a, this middle term here, which gives us b over 2a. Then we're going to square that. b over 2a squared is b squared over, and square both factors in the denominator. It's going to be 4a squared. That's what I'm going to add to both sides. So b over 4a squared, b over 4a squared. Now we simplify the right-hand side and factor the left-hand side. Now the factoring is actually, it looks complicated here because we've got to factor this expression. But remember the shortcut. The shortcut told us that the thing that goes inside is simply the result of taking half the middle term. So the left-hand side becomes x plus b over 2a quantity squared. On the right-hand side, all I did was find the common denominator. The common denominator between a and 4a squared is going to be 4a squared. So I got to multiply in a 4 and an a on bottom and a 4 and an a on top. That gives me, by the way, this should be squared here and here. Sorry for that mistake. Up here I end up with a 4ac. Up here I end up with a b squared. This is negative, so I can write that as b squared minus 4ac. Now you begin to see something coming into focus here, because b squared minus 4ac, that's the discriminant. We've seen that before in our quadratic formula. Now, finally, we use the square root property. Which means I can take the square root of both sides. Take the square root here, put a plus or minus out front. On the left-hand side, the square and the square root cancel, so I have x plus b over 2a. On the right-hand side, I'm going to take the square root of the top over the square root of the bottom. The square root of the top still leaves me with plus or minus the square root of b squared minus 4ac. The square root of 4a squared is 2a. Again, it's coming into focus. Now move the b over 2a to the other side by subtracting it across. You have a common denominator, so you can go ahead and combine those. By subtracting across, it becomes negative, so now you end up with b is negative, so negative b plus or minus the square root of b squared minus 4ac all over 2a. And guess what? There's your quadratic formula, just a result of completing the square.